Lesson 5.2, Direct Variation. The objective of this lesson is to write and graph an equation of a direct variation. Vocabulary. Direct variation is a linear function defined by an equation of the form y equals kx, where k is not equal to 0. An example would be y equals 18x. Constant of variation for a direct variation. The non-zero constant k in the function y equals kx. For example, the direct variation y equals 24x, 24 is the constant of variation. Essential understanding. If the ratio of two variables is constant, then the variables have a special relationship known as direct variation. To determine whether an equation represents a direct variation, solve it for y. If you can write the equation in the form y equals kx, where k is not equal to 0, it represents a direct variation. So let's look at a couple of problems. Problem number 1. Does the equation represent a direct variation, and if so, find the constant of variation? 7y equals 2x. So to determine if this is direct variation, we have to solve it for y. So to solve this equation for y, we are simply going to divide both sides by 7, and we get the equation y equals 2 over 7x. The equation has the form y equals kx, so the equation is a direct variation, and the constant of variation is 2 over 7. Let's look at 3y plus 4x equals 8. Again, we have to solve for y, so the first thing we have to do is subtract 4x from both sides, and then we get 3y equals 8 minus 4x, and then we divide everything by 3, and we get the equation y equals 8 over 3 minus 4/3 x. You cannot write the equation in the form y equals kx, therefore this equation is not direct variation. Writing a direct variation equation. To write an equation for a direct variation, first find the constant of variation k using an ordered pair other than 0, 0 that you know is a solution of the equation. Problem 2. Suppose y varies directly with x and y equals 35 when x equals 5. What direct variation equation relates x and y, and what is the value of y when x is equal to 9? So we know that the direct variation equation is y equals kx. Well, we are given what y equals and what x is equal to, so we can just substitute those values in and solve for k. So 35 equals k times 5, which simplifies to 35 equals 5k. Step 3, solve for k by dividing by 5, each side by 5, and 7 equals k. But remember, we have to write the direct variation equation. So all you have to do is, step 4, write the equation, substitute 7 for k in y equals kx. So the direct variation equation is y equals 7x. And then the second part was, what is the value of y when x is equal to 9? So all you have to do is substitute 9 for x in this direct variation equation, so therefore y is equal to 7 times 9, or 63, when x is equal to 9. Concept summary. Graphs of direct variation. The graph of a direct variation equation y equals kx is a line with the following properties. The line passes through 0, 0, and the slope of the line is k. So when k is greater than 0, the slope is positive, and it goes through the point 0, 0. When k is a number less than 3, the slope is negative, and it goes through the point 0, 0. You can rewrite a direct variation equation y equals kx as y over x equals k. When a set of data pairs x, y vary directly, y over x is the constant of variation. It is the same for each data pair. Problem 4. For the data in the table, does y vary directly with x? And if so, write an equation for the direct variation. This is similar to what we were doing in 5.1 when we were figuring out the rate of change. So we need to find y over x for each ordered pair. 6 divided by 4, 12 divided by 8, 15 divided by 10. They are all equal to the same number, which is 1.5. Therefore, 1.5 is the constant of variation, and the direct variation equation is simply y equals 1.5x. So let's look at a couple sample problems. Does 4x plus 5y equals 0 represent a direct variation, and if so, find the constant of variation? So we need to first solve this equation for y. First thing we're going to do here is subtract 4x. This is similar to solving literal equations back in chapter 2. we get 5y equals 0 minus 4x is just negative 4x. And then our last step here is to divide both sides by 5. So we get the equation y equals negative 4 over 5x. Let's go back and answer the question. Does this equation represent a direct variation? Well, remember, the direct variation is y equals kx. When we solved for y, we got y equals negative 4 over 5x, which is the format. So yes, and the constant of variation would be k, which in this case is negative 4/5. Let's do one more. It says, suppose y varies directly with x and y equals 10 when x is equal to negative 2. What direct variation equation relates x and y, and what is the value of y when x is equal to 15? So let's start off with y equals kx, which is the direct variation equation. We know our y, we know our x, so let's substitute those values in. 10 equals negative 2 times k. And let's solve for k by dividing both sides by negative 2. So we get negative 5 equals k. So now we have our constant of variation. So the direct variation equation that relates x and y would be y equals negative 5x. That would be the equation. And then they also want to know what is the value of y when x is negative 15. So when x is negative 15, we're just going to substitute that into the direct variation equation. So negative 5 times negative 15 is positive 75. So when x is negative 15, y is equal to 75.